How old is it your son or?
So son, he's gonna be 3 in August.
Okay.
Then wife's pregnant, and
Oh,
we have
congrats.
another one in August.
Oh, that's exciting.
So hopefully everything goes well. But yeah, they're both birthdays will be first week of our first week of August. So,
Okay. Oh yeah, that's my daughter Sue's also. Second week on like 11th.
yeah, I think we're expecting big things.
Okay.
But
Oh,
yeah,
dude, that's cool.
yeah. So. But yeah, super excited. So
That's awesome. We should grab lunch sometime. I mean, I live right by, like, I'm true in Hobson. That's right by the university. So
Yeah,
show me around. I've always been curious about PFS, like, you know,
Yeah.
IT stuff. So
yeah, no, it's been interesting, especially since it's now just PFW.
right, it's just
a lot
PFS.
of West Lafayette.
Yeah, that's cool.
Yeah, we'll grab lunch or something.
Yeah, that'd be cool. Good to see you, man. Carrie Roberts labs still on. Okay, yeah. Probably should.
Hang on.
Yeah, I'm gonna hang out here for this, and then you're doing errands right next. Okay.
We have a break after. Yeah, after this guy, we have a break. Take a 15-minute break. Then
Okay. Seen her in there.
You're good.
Okay, cool.
I just wanted to show Tito where
Yep.
the audio is coming in. I would be live streamed left and right. That's the music. Top max, as long as you have something going on here. Let's close this mail. Is there something coming up already? You have music? Okay. So you have music and then the live stream will be here. Yeah, it's linked stereo, so automatically pan. Just watch the volume coming in. And that's it. There's your couple of your mics just in case. And then that's your live stream. You don't have to worry about anything like this. This is fixing to the camera that's going to the stream. But when you're but actually, it's even set up as it's post fade, so that way they can hear channels, whatever mics you have up and going, she can hear the questions. But that's already set up.
so that's just what this is. So everything pulled off this one. No,
Correct. Obviously, this is not going to this. Right. So we should be sorted.
sweet. I think I can handle this from here on.
Huh?
I can handle this from.
Yeah. And then if you want to, Ryan, if you
Yes.
want to set your computer up
Yeah,
here,
I think I will.
you know, whatever, we can just make a little space for you right here. We'll just
Oh,
take
thank
one
you,
of these
sir.
cables. There are my glasses.
I was gonna say, I'm like, I think those are yours.
No, because I was squinting hard the whole time. I'm like, I know they're somewhere.
What was that?
Hey-
let's turn this
Hey,
one
Carrie,
of
it's
these
Ryan.
mics
Can you hear me?
on. Yeah, let me just turn this mic on.
Hello?
1, 2, 2, 2, 1, 2.
Yeah.
Okay,
Carrie, can you hear me?
Yeah.
Awesome. outside we share it today. Cool, we're just getting set up here.
Here's number two, just in case. 1, 2, 2, 1, 2.
Just gives like 1 minute.
1, 2.
Make sure I get the codes. Actually, I'll get this.
Tito, I'm just shutting this off. Okay, it's up, it's on. I think you heard it. His mic is on.
Carrie, I don't think you can hear me, but you probably can't see me. We can see you. So it looks great. We've got a nice big screen. I'll send you a screenshot. So yeah, I introduced myself earlier. Ryan, network engineer at Walmart Cybersecurity, and I had the pleasure and the privilege of presenting Carrie Roberts, who is on the red team. What is your ETE, right? Or your enterprise technical expert, right, Carrie? I forget your exact title.
Just like defense engineer. That's the easy way to say it.
Yeah. So, yeah, automation red team. So I will, without much further ado, I'll let Carrie just share a little bit about what's going on. I will get them.
V8.
Have you guys already got the codes for the lab yet? If not, I will get this to you, and then she can explain more about that. Yeah, Carrie, go ahead and take it away. And if you do have questions, I do have the mic, so I can pass it around and you can give us too. Okay. Cool. Thanks, Carrie.
Cool. How many people do we have in the room?
Looks like we have about 10 or so far right now. There's still
Okay.
we're talking, but yeah.
Cool. I just want to decide how nervous I should be. Okay, so I'm 10% nervous. No, just kidding. But sometimes it's nice to know there's really like a live person. I've been teaching these classes online the last 2 years, and it's really hard to get used to just staring at your screen and trying to believe that there's somebody actually listening on the other side. So, but that's cool. I can kind of see the room. I can see a couple of back sides of the heads at least. So if you fall asleep now and you're one of those 3 heads and your head starts bobbing, I'm good enough. Okay. So anyways, there's a link to some slides here. I have some links prepared for you guys, like 4 links, the links to the slides, the links to the labs, the links, yeah, some good stuff like that. If you can have this link right here, just type it in, that's MKL in a 1, but you would get access to everything from that 1 link. But I'll also figure out how to just maybe give the organizers those links in a way you guys can just click on them. But we're going to talk about getting started with Atomic Red Team. And I'm Carrie Roberts, and I started out as a web app developer back like 2006 to 10 or so. And then my web app failed a security audit or pen test. And at that time, I'd never even heard of a pen test. And I didn't even know that my management had ordered a pen test for our application because our group was new to developing web apps. This was our first web app. And I was the primary, I developed most of the web apps. So, if it was bad, it was my fault. And so he walks by one day and drops a report on my desk and points at it and says, I need you to fix this stuff. And I didn't even know what he was talking about. I pick up the report. It's this report with a bunch of red text all over it. Like, you have critical security vulnerabilities in your app. And the first one was SQL injection, which said we have SQL injection. You have SQL injection in your site pretty much everywhere. It said, as well as cross-site scripting. This means that we could do anything we want to your database, change it, read everything, erase it, add stuff. And I was just in shock. And I went back to my development machine and they gave good examples of how to do it. I tried what they said and it worked. And I was just flabbergasted. And I went home from work that day really like wanting to quit because I had just completely failed. We were soon to release the web app, and I about released this web app. It was complete hackable. I had just graduated with a computer science, master's in computer science in 2006. So now it's 2010. and I'm finding out that there's this whole security world that I knew nothing about, nothing. So I'm a developer knowing nothing about security, and also frustrated that they would give me a master's or teach me a master's program and never say anything about security. So anyways, I went home, super shoulders hung low, tell my husband about it, and kind of at that point where I'm like, I'm just going to quit. I can't be a developer. But he kind of encouraged me. And so I decided to get back on the horse and actually embrace security. So I was like, this inspires me to go out and try to be like a security expert. So then I sought out some training. I got recommended to SANS organization. I took classes there. It was the best training I'd ever taken or seen. It was awesome. My work was paying for it. So I took a bunch of them, and I ended up getting their master's degree, and it was super cool. And I learned a ton. And now at least I feel comfortable being a developer and knowing some about security. So that's cool. So I really like that story, because it really was that moment of almost quitting and then overcoming that. So that's cool. And now, you know, after I finished my SANS training, I spent 3 years as a pen tester for Black Hills Information Security, and then moved to the Walmart Red Team for 2 years. And then I switched to the Walmart Blue Team for the last 3 years, because I really wanted to know what happens on the other side of the curtain. So on Red Team, we throw, you know, a lot of attacks and techniques at the Blue Team, and some things work and some things don't. And we really didn't get much time to get into the details of what worked and what didn't afterwards. So I wanted to join the Blue Team really at the time to become a better Red Teamer, to figure out what techniques work the best and why they're hard to defend against and stuff like that. But I've actually really enjoyed being on the Blue Team, because I'm really kind of red/blue on the Blue Team, because I focus on these attack techniques through Atomic Red Team, which is scripted cyber attacks. And, you know, I get to emulate these attacks and look at all those details. I wanted to know, like, how is this detected? What little trick could you do to make it not detected? But then I follow that up with actually making those detections. So it's really rewarding. So today we're going to talk about Atomic Red Team and how you might also be able to use it. It's full of scripted cyber attacks. So if you wondered, how does an attacker do the things I read about on the news? How do they get credentials? How do they password spray? How do they exfil data? What are the ways they do it? Well, this repository is full of about 1,000 different ways to do all the tactics and techniques that you read about in MITRE ATT&CK that you see on the news that are being used by real adversaries today. It was started originally in 2017 by the Red Canary Company out of Colorado, which does manage detection and response and also security research. And but it is free and open source project. There's a whole community, actually over 250 developers now that have contributed to the project. And I'm one of the maintainers of the project. So if you were to contribute something at some point to the project, I would probably be reviewing it before it became part of the community project. Whoops, I'm going the wrong direction. Okay, so this 1 hour webcast followed by 2 hours a lot of time is really a subsection of a larger class I teach about attack emulation tools, and where we go over Atomic Red Team in more detail. We go over MITRE ATT&CK and the Attack Navigator, Vector, which is a purple team reporting tool that's also free but not open source, Prelude Operator, which has a community edition that's free, that's C2 style attack emulation tool, and also MITRE Caldera, which is the same C2 style but different technology, and then Purple Sharp, which is a little different. Anyways, that's what we go over in the full day class, but that is not paid. It's I mean, that's not free. That's a paid class that you can learn about. I got a link to it at the end. Yeah, today's 1 hour of lecture and you've got 2 hours of lab time. I didn't update the slide, but I'm actually giving you 2 days this time to use your 2 hours, and it's actually 3 hours. So you got up to 3 hours that you can use on in what your lab time is it's a virtual machine in Azure's in the cloud that you can just RDP to. So it's super easy to get to from any operating system. You just RDP to this machine. I'm actually RDP to one of the lab VMs that I'm presenting from right now. So you'll get to see what the lab VM looks like. But you go there, there's a link to the labs there, and you run the labs there. So you don't have to worry about blowing up some computer you're not supposed to break, or setting off alerts at your work or anything like that. It's a safe place to play. And you'll have until the end of the day, Sunday, to actually use your 3 hours. So you're going to have access to a control panel where you can start and stop your VM. Maybe you're going to start it up, use it for an hour, take a break, come back tomorrow, use the last 2 hours, whatever. So you do have up to the end of the day tomorrow to use your 3 hours of lab time. Oh, and I could swear I'm sharing the wrong slides because I did update some of this stuff. Support I usually do through Discord. I tried to join the Discord for this, and it said, sorry, we couldn't join you. So I'll try to figure that out so that I can be on Discord if you have questions. It's or 1=1 on Discord when I eventually get.
Yeah, and after the session, I do have the codes for anyone who's interested for the last.
Okay, cool. Let's see. So why emulate attacks? So we can use these emulated attacks. Well, one, just to learn about them, like as maybe you're a red team and you're just curious, like what are some cool things I can do maybe for persistence, and you can look in the persistence category and you can learn about some of these ways of doing things. But also from my perspective is to develop detection. So it's really hard to write a detection if you don't have the data there of what you're trying to actually find. So if you write a detection that looks for XYZ and you run it on your environment and it finds nothing, then you want to have a good feeling. You're like, cool, XYZ isn't happening in my environment. But what it really could be is you wrote your detection logic wrong and it wouldn't even find it in the first place. But since there's no examples in your data, you're not sure if your detection even works. You just know it's returning nothing. So you really need to emulate this in a way that you can see if your detection would really find it. So you need that needle in the haystack to know that you're able to find needles. So you can use these scripted cyber attacks from Atomic Red Team to give you that thing to search for to validate your detection works. But even almost really more importantly, because honestly, you could do without automating your attack, you could kind of just do it by hand. You could read a blog and you could manually figure it out and do it by hand. But what's really cool about the scripted cyber attacks is that you could set up automation to run these like weekly. So you could run all of your scripted cyber attacks every week, and you can compare that every week to your detections because things break over time. So I have the chain over there. There's a lot of things that have to be in place for your whole process to work. So you have your technology that have to work, you have your network that has to work, and your certificates, and then you have your people that need to really be reviewing your alerts, and then they need to raise that to your incident response team or whatever. And you want to test that whole process because at any time, any week, one of those things could break, and the whole, you're never getting to the end of your process. So with these automated attacks, you can automate a dashboard that shows you last week you were detecting these 10 things. This week, you're only detecting 9. So something happened. Somebody changed the alert logic. Maybe Microsoft changed the way they're reporting on something. Maybe a certificate broke on the event forwarder. You know, the reasons are like literally endless. I've heard millions of reasons of why something went wrong that you wouldn't know about if you weren't testing on a regular basis to validate. And then additional things, we can't record and store everything that happens on every computer because of the massive amount of data it is. So we need a way to pare that down to only the important things. well, how do we decide what's important? Well, if we emulate these attacks, we can say, well, and if we want to be able to know that this attack happened, we need to keep track of this one, maybe event ID, and on all computers, or there's no way for us to know it. So now we have a way to justify what's important to keep and what's not, based on whether it's going to help us detect something, or maybe there's a bunch of really noisy events that even if we kept track of them, they weren't going to help us detect any of the things we're interested in. And we could also evaluate security products. Maybe we have A, B, and C security products, and we find out that C is just doing a little bit of what A and B already does, and we could get rid of security product C. So before we talk about atomic red team, we really need to make sure, and do a really tiny crash course into MITRE ATT&CK and MITRE's nonprofit government sponsored research and development project, where they take input from industries across the world on what attacks are seeing, cyber attacks are seen done against them, and they categorize them in a big matrix, which you see here, of tactics and techniques. So across the top in red are tactics. The tactics, so large groupings of things that attackers tend to do is they first try to initially get access to your system, and then they want to execute code. They want to make sure when you restart your computer or lose the network and get it back that they still have access. So they'll do things for persistence, etc. And then within each of those tactics, there's techniques, which is highlighted in blue there. And those techniques, like for example, if the attacker is trying to get credential access, they might try to brute force password, which is like guessing a user's passwords by guessing 10 million passwords for that user till they find it. Or they might do a password spray, which is a variation of that. We also see down there input capture, which is like keyboard logger. So that's one way. Once an attacker can execute code on your system, they just watch everything you type on the keyboard. So we can learn more about each of these tactics, but by going to MITRE ATT&CK website, there's tons of great information in there about each of these tactics and techniques. But the one thing it doesn't have is really very many procedural examples of, if you want to do this, here's 10 different commands you can use to do it in 10 different ways that you would have to make sure you detect. And that's where Atomic Red Team fills in. So the important thing to know about MITRE ATT&CK for our discussion today is that each one of these techniques, which I have highlighted in red as one technique, under the tactic of credential access, has a technique number, and it starts with the T and then 4 digits, or possibly 4 digits dot 3 digits, which that would be a sub technique. So you have your major technique T1003, and then sometimes they're breaking down into some smaller subcategories by sub technique number. So you might see that form. So everything in Atomic Red Team is organized by the MITRE technique number. So you'll be seeing these T number things a lot in our discussion today. So let's look at some examples of atomic tests. So here we have one called an atomic test that's called disable UAC user access control using reg.exe, the reg editing tool in Windows. So this falls under technique T1548 and subtechnique number 2, which you could read more information in MITRE about that. But this is what an atomic test will look like. It has a description about what the test is, whether it's for Windows, Linux, or Mac, because Atomic Red Team supports and has tests for all 3 operating systems, and actually cloud stuff too. And it tells you should run this on the command prompt as opposed to PowerShell on Windows, or for Linux and Mac would be bash, or I can't remember what else they use on Linux and Mac, but and then I'll tell you whether you need to be admin to successfully run it. So this one you need to be admin. So the scripted attack is literally this one line here, regexe add, and you're just adding a registry key that sets a value for enable LUA to 0, where it's normally 1 by default. So user access control is that box that pops up, like, do you want to allow such and such a program to make changes to your computer, yes or no? So as an attacker, there's a desire to disable that so that they don't make people suspicious, because if you get one of those on your computer and you weren't even doing anything, you would wonder if maybe you'd be hacked, or even the attacker doesn't want the user to end up pushing no, because then the attacker's code can't run. So if they can turn that off, then they can run their code without waiting for hopefully a victim to push yes, allow. And then it also provides a helpful cleanup command, which is kind of reverting whatever it does in the attack command. So it's just setting that registry key value back to 1. So that's a really simple example of atomic test. There's some more complicated ones, which really helps you understand the value of automating this, but that's one example of atomic test. Another example of atomic test in atomic red team. And sometimes you'll hear me call these tests atomics for short. So an atomic is a scripted cyber attack under one of these techniques. So here we're dumping 3 registry hives that contain credential information that which attackers can take offline and pull out your passwords, local passwords. So if we see somebody copying out these 3 registry hives, which they can do with this reg save command, then we want to know that, because it's probably bad news for us. So if we emulate that, we can say if somebody does these 3 commands in our environment, do we have something that would block it? Do we have something that would detect? If we don't have something to detect it, let's write something so we can be alerted. And then here we have another example under T1078, which is enabling the guest account. So Windows has a guest account on it by default. Yeah, it's not enabled, so people can't use it. But if an attacker is trying to get that persistence, they want to be able to get back into the computer later, even after the normal user changes their password every 3 months or whatever, they might turn on this guest account because it's kind of a stealthy way for them to get access. So instead of adding a new account, which may be monitored by the defense and kept an eye on, they could just enable this account that's already there. And in this case, they are also turning on remote desktop access. So that's super suspicious. If you ever saw that in your environment, the guest account turned on and RDP access enabled, that should definitely worry you. But honestly, I would bet most environments where that happened, there would be no like AV or built-in anything that would block that or even tell you that it happened. So, you know, we have to do it ourselves. We have to say, well, I definitely don't want that happening in my environment. Let me see what happens if I do it. Oh, nothing. We didn't even hear. We don't even know. And then you can fill that detection gap. Okay, so now we're moving. So we got this little idea that Atomic Red Team is this library of scripted attacks. It literally is just a list of commands and instructions. Run this here, admin or not, here's the commands. And then separate from that, but related, is we have execution frameworks, which right now without an execution framework, we'd have to go into each of these tests. We'd have to copy that line out, which sometimes it's a lot more than one line and sometimes it's a lot more complicated. We'd have to copy that out, open up command prompt or PowerShell, paste it in and run it. And so that's very manual. And if we want to automate that or just make our lives easier in general, we can use an execution framework, which is something that knows how to read the library and follow the instructions for you. So it's kind of like a menu or remote control for those tests where you can just go through and say, please run that one, that one, that one, that one, without all the copy and paste business. And there's a lot of different execution frameworks you can use with different programming languages that read the library that work better or not on different operating systems. There's one that Red Canary provides in one of their repositories called Invoke Atomic Red Team. It's a PowerShell framework. It works cross-platform if you install PowerShell Core on Mac and Linux. And it's a good, simple execution framework to start with. And then you can go into some of your more advanced frameworks, which are like Prelude Operator, MITRE, Caldera, and even Vector gives you some options for executing atomic tests in an automated way. So just remember that the execution frameworks there's a lot of them. There even several commercial tools are execution frameworks for Atomic Red Team, can execute Atomic Red Team's tests, like Scythe is an example of a commercial tool that you can execute Atomic Red Team tests. So there's a wide variety So really in this discussion, the real value here is that library of scripted attacks. The execution framework is kind of dime a dozen. There's a bunch of different ones. You can use any of them. It really doesn't matter. If you don't like the PowerShell one, you can use the Go language one or the C2 type one or the commercial one. So we're just going to use one of them as a tool to utilize the library, but don't get too hung up if you don't like the execution framework, because you can use any execution framework. It doesn't matter. So we're going to skip out of this discussion now, and we're going to go look at Atomic Red Team. So I'm presenting here from the lab VM. So when you RDP, I should move this off the screen. When you RDP, you'll get a desktop just like this, and you'll have these links here. You want to start up Google Chrome, and then you'll have these bookmarks here. So the first bookmark is the labs, which I have open here. This is what the labs look like. You got a link to the slides, and there's 7 labs, and you're going to install Atomic Red Team and do all the things. And then there's a link here to joining the Atomic Red Team Slack. So that's free Slack workspace. Over 4,000 people who discuss attack emulation type stuff, and I'm always on there too. And it's good supportive community. So you have the links here to Atomic Red Team, MITRE ATT&CK. So we'll go over and use this link to get to Atomic Red Team. So Atomic Red Team is a project housed in, let me zoom this in a little bit, in GitHub, which is a great place to put things that are code-like things where multiple people are contributing, because it keeps track of everybody's changes and doesn't let them be overwritten and make sure they're approved and all that. So here we are in Red Canary's repository or account on GitHub, looking at this public Atomic Red Team project, and we have all this stuff in a little README down here. And this can be overwhelming when you come in, because you're like, oh my gosh, look at all this stuff. I don't know what to do. But really, a lot of this stuff nobody else needs to pay attention to. It's for automation and legal type things. But really, everything we're interested in is in this one folder, Atomics. This is where the library is. Inside the library, you see tons of technique numbers, which now we recognize is coming from MITRE ATT&CK. And inside of each technique number are all the variations of atomic tests or scripted cyber attacks that can do that technique. So that's pretty cool. But it's important to note that each of these projects, Atomic Red Team and the execution framework that Red Canary provides, has a great wiki. So if we go to the wiki, we can see about getting started, how to get to execution frameworks, how to contribute if we want to contribute. So make sure you check that out. So inside this library, with the exception of the indexes folder, which we could look at real quick, we could go to like the CSV index and say, what tests does Atomic Red Team have for Windows? We could click on this, and we see under the tactic of MITRE ATT&CK of credential access and this technique number, we have a test called Rubius AS Reparos, and we have WinPwn stuff, Session Gopher, all this stuff, all the way, like 800 tests long, all the way through the end. So you get a quick idea of how many tests are in there, but those indexes are just handy sometimes if you're looking for specific tests. But for the most part, we have these technique number folders. We could go into one of these techniques like T1016, and inside each technique folder, you'll always find a same technique number .yaml or .markdown and .markdown. So you always find those two. The YAML is the official source for the scripted cyber attacks. It's the machine readable, very organized and structured format. We can kind of make sense of what it's here. We have a list of atomic tests. So we have dash name. This is one test. And we have another like dash name here. This is another test, but it's really like ugly as a human to read YAML. It's nice for a computer, ugly for a human. So this project has automation that builds from each YAML file. It keeps up to date and always builds this markdown version. So it's machine generated, but it's a very friendly way to look at the same information. So when you're browsing around on the web, really, you want to look at this markdown file. It has the same information, but it's just much more readable. So we're going to look at this markdown file. This markdown file has the name of the tactic or the technique at the top. So technique 1016 MITRE says is system network configuration discovery. And then it copies in right from MITRE ATT&CK's website, the description. And so that's handy. So you don't have to bounce back and forth as much. And then it's got a nice clickable list. So this technique has 8 different scripted cyber attacks. You could run one that emulates the commands that we're seeing CAC malware do. And then there's just a bunch of different variations of discovering network configuration information that attackers use. I just barely started getting an echo. I don't know if something changed, but I'm starting to hear myself. So you can also list open egress ports. There's some tests for Mac in here. So let's take a look at this first test. It's very simple. It's just says this is one thing we see attackers doing a lot, is just doing your basic IP config, netsh, ARP listing. So we could copy out these commands and run them and say, yeah, that's kind of suspicious. If somebody's running like just back to back all these recon type commands, maybe we would want to know. And if it turns out it's just our IT person, you know, well, that's fine. But you know, that doesn't happen very often. So we really want to keep an eye on it. So that's an example. We got test number 3 here. It's designed for Mac OS and Linux. So that wouldn't apply to Windows. So I want to show you test number 5 because it's one of the more complicated tests. So we have some configurable variables we can use. So we can define where we want our output file written. We can define what ports we want to scan. So this is a test that tries to find open ports out of the network, and it does the nmap top 128 by default, but maybe we only want to scan a couple ports, so we can configure that. So we see in this little PowerShell script, which is the scripted cyber attack, that there's some special notation here that isn't actually PowerShell. It's this hashtag squiggly and then the name of a variable, which matches up here. So here we have output file. So actually to run the import file, actually to run this atomic test, if we were going to do it manually, we'd have to copy this code out. We'd have to, everywhere we see the hashtag squiggly, we'd have to replace it with the default value here or our own custom value. So we would say, write it to the desktop, open ports.txt, or maybe somewhere else. So now you can see if you wanted to run this by hand, it gets to be a huge pain because we had to copy and paste all those variables in. And also we'd have to do it for the cleanup commands. We'd have to paste that in. And then we wanted to check that the atomic tests also have a nice thing where it will check to see if you have everything you need to run this test. Like maybe certain tests have to be done on Windows servers instead of Windows clients, or maybe you have to have 7-zip installed to run this test, and this will check it. So it has some commands that will check if you meet that, and so you run these commands and it'll tell you yes or no, you have it. And if you don't, you can run the get prereq command. So in this case, you need to have this port file on disk and it'll check. And if you don't, it'll go fetch it from the web. So it'll invoke a web request and get it. So it just makes it really handy to do in an automated way, which we can do with the execution framework. So this example of tests we really would hate to do by hand. Plus, we don't, if we're going to run these atomic tests every week to validate detections, we don't want a human to have to sit there and copy and paste stuff out all day. We just want a script to do it. And so we definitely want that execution framework to automate this around the clock kind of validation. Okay, so I've already got Atomic Red Team, the execution framework, and the library installed on this computer, but it's the first lab that you do, and you have those instructions. Even if you don't end up connecting to the lab, you still will have access to this link to the labs, and they're very verbose documents. They're downloadable. This link will continue to work for the foreseeable future, but it tells you all about installing Atomic Red Team and the different execution frameworks and commands to run. And you can definitely do these labs from your own Windows VM. There's nothing special about this VM. It's a basic Windows VM that I just added shortcuts to, and that's it. So I haven't done anything to make this like somehow work well or not work well with Atomic Red Team. So you could always do these next week on your own VM. You just want to be careful like about doing it on your work network, because the library is full of scripted cyber attacks. And when you download that library, you're going to set off a lot of alerts in a work type environment. So you don't want to get in trouble for doing that. Okay, so I'm going to start up PowerShell. And once you've installed Atomic Red Team, you have this function available to you called invoke atomic test. And then you can give it a technique number like T1016. And you can start out with a little flag that says, just show me the brief details, which is the title of each test. So we do this and we see there's test 1, 2, 4, 5, 6, 7, which you might remember from that markdown we were looking at, that there were those tests, and test number 3 doesn't show up. We looked at that one. That was something for Mac OS and Linux. And since we're not on that operating system, those operating systems, it's not showing us that test because we can't execute it here on Windows. So that's why we're missing some numbers for tests that don't apply to our current operating system. And we can also do there's a little magical technique number where we can just say all, and it literally would run all if I pushed enter right now. It's not a good idea just because so many things on the systems changes. It basically, you can't make sense of so many changes at once anyway, so it's pointless to do. Plus, you get some really weird interactions, like some tests disable PowerShell and disable command prompt and disable, I don't know, your mouse and all this stuff. So you basically blow up your computer if you do that. But if you wanted to, you could, especially in this lab environment. But you could do all and then show details brief. And you could get a quick idea on Windows, all the tests you have available. So now it's listing out all the technique numbers and atomic test numbers that you could run. And you see there's quite a few, and I'm going to cancel out because we don't want to wait for all that, but you do get an idea though. So let's take a specific atomic test like T1016, and instead of show details brief, well, actually, yeah, show details brief. We're interested in test number 1. So I'm going to say test number 1, and I could also say 1, 4, 5 like that. But for now, we'll just do 1 test number. And I want to see, instead of the brief details, I want to see the full details. So now we've got kind of a command line version of that markdown file where it's telling us the name, the technique, and there's also this GUID. Each test has a unique GUID, which is just really helpful when you're running things from a script instead of using like test numbers or test names, because they can change, but that's what the GUID is. But this, it says, to run this emulated attack, you should start up command prompt. You don't need to be admin, and you should run these commands. Again, that would be easy to copy and paste, but we're just showing an example of how to use the execution framework. So if we take off the show details, it will actually run these commands and give us the results back. So now it just ran those 5 commands, and we have, doesn't look like it ran 5 commands. But yeah, I guess it did. So we just emulated that attack, and now we could go into our detection telemetry and see if anything got noticed. Let's see, I need to bring up my notes for what I wanted to show you next. Okay, so let's look at that disable UAC test. It's a test that has cleanup commands, just so we can see how the execution framework helps us with cleanup commands. So that was 15.48.0.0.2. And let's remind ourselves what tests are in there. And we wanted bypass UAC using reg.exe. That's test number 8. So we could say, we could do this again and say test number 8, but there's a shorthand for this too. If we just do -8, that's the same thing. So we're going to look at test number 8. We'll show the details, the full details. And again, we just see these reg add command for the command, and then the cleanup command. So, we're going to use another thing just to make sure we have everything we need for this test. We're going to do the check prereqs. So it'll run that code to decide if we have everything set to successfully run this. And it gives us a red message and then says prerequisites not met. You need to be admin when you run this. So actually to run this, we're going to need to start up PowerShell as an admin. And here's that prompt that we're actually trying to disable the UAC prompt. And we'll say, yes, allow this to run. That's the thing attackers don't want you to say no to. And then we need to run this over here, which we will. But before we do, we'll actually double check what our registry key is. So we can say get item property HKALM. And then we paste this in. Oops, not that. And then the name is enable LUA. Let me check that. So it's currently 1. That's the default value in Windows. That's the, more safe value. So it's 1, and this attack is going to change it to 0. So we can just verify that. So now we want to repeat the same command, invoke atomic test number 8. We'll copy this out, but we need to do it from an admin prompt. Actually, I'll do it right here just to show you what happens. Copy and pasting in PowerShell is hard. Okay, there we go. And it says access is denied. So that would have let us know we weren't making it either. All right, copy and paste. And then T1548. Okay, so the operation completed successfully. It says we have to restart our computer for it to take effect, but for our purposes, we've made the change. We can see if we detect it. We don't need to restart. So now we'll get this and we see that it's changed to 0 here. And then this test also, like if we were testing, we wouldn't want to leave our system in the state. So that's why these cleanup commands are handy. And so we run this cleanup command is going to set that back for us. So all we have to do to run cleanup is add -cleanup. And then we've set that enable LUA back to 1. So that's how it works. You run the tests, you clean up after at some point, after you finish maybe developing your detection. And then that allows you to run it again, or like if you're scripting things, you would script it to run the test and then clean up afterwards. So it could run it again maybe next week or something. So that's how that works. We're going to look at one more example. We have 15 minutes. So one more example of a more complicated test, which is invoke atomic test T1485. And we're going to look at this first test, overwrite a file with sysinternals sdelete. So Microsoft provides a tool called, or a repository called sysinternals that has a bunch of nifty little tools. One of them is a tool called sdelete, which is for secure delete. It overwrites a file instead of just marking it as deleted, making it non-recoverable by forensics analysts. So this is a technique and tactic that attackers use to make it hard for the defense to find out what they actually did. So they'll securely overwrite a file to make it not recoverable afterwards. And so let's take a look at this test number 1, and show the details of this. So we got our attack commands, and here this test has some input arguments. So input arguments shown red. So we see all the little variables here. So we can configure what file we want to delete with this test, and also where our secure delete executable resides. So maybe in your environment, you actually provide in the ctools directory sdelete for some reason, and you could just use that because you already know it's on the machine. So you could point to that, or you could just leave it the default, which is using sdelete out of the temp directory, and these get prereqs will get it there for you. So you have the commands here with input args, but then you also have the same things with the default inputs already put in. So we see for file to delete, it's going to default to using environment temp 1485. And then for the location of sdelete, it's going to default to using this unless you specify something else when you run it. And so we could try to run this test right now, but we actually don't have the delete tool on this computer. So, but let's just say we tried to run it anyways. So we run test number 1. And it errors out and said the term delete isn't recognized. I don't know what to do when you tell me to run delete. So we could have actually found that out by running the check prereqs command. So we run that and it says, you don't have what you need. You need to have the secure delete tool and it needs to be at the default location here. And it says, try installing the prereqs with the get prereqs switch. So to prepare to run this test, all we have to do is use this automation, get prereqs, which downloads the zip file of the delete from Microsoft, unzips it and puts it where it needs to go. So now it says prerequisites successfully met. We're ready to go. And now we try to run this test again. We just remove the parameters here. And now it runs it without error. And it says successfully overwrote this test file T1485. So we just ran it. So that's cool. So some other options we have, let's see, we have 12 minutes. Some other options we have with the execution framework is we can prompt for input arguments. So instead of using those default values for where delete is, we can have a prompt us for it. And it says, okay, well, for this variable, the delete_exe, the default value is this. If you want to use the default, just press enter here or type in something else if you want to set it to something else. So we'll use the default here. And then here I could type in, no, don't delete this temporary file from the temp directory. Maybe I put some on the desktop and I give it that path and delete it. I won't show that example, but you get the idea. But this is a very interactive way to do it, which is nice when we're just playing around like this. But there's also a scripted way to do it where you define a variable with your input arguments and then you pass that variable. And so you don't have to, again, have a human there typing in your custom input args from week to week. So I want to show you that Atomic Red Team repository. So we were over here in Red Canary Atomic Red Team. So this is where the Atomics folder is. I want to back up one level. So I'm going to back up to Red Canary Co. and point out that, remember, these two things are different. You got Atomic Red Team, which is the library scripted cyber attacks. And then you have Invoke Atomic Red Team, which is an example of one of the execution frameworks. This one happens to be provided by Red Canary. Well, it's open source too, so kind of the community. And so we're going to, instead of going into Atomic Red Team, I'm going to go over here to the execution framework, which knows how to read that library and execute it. So this execution framework has an awesome wiki here. So we click on the wiki and it tells you how to install Atomic Red Team, how to import the PowerShell module so you can use it, how to list atomic tests, check and get your prerequisites, and execute atomic tests locally and remotely. So you can actually execute atomic tests against the machine where you installed Atomic Red Team, which is what we're doing in the labs, but you can also do it against a remote machine. So we can install Atomic Red Team here and we could point it at other machines and say, run this emulation on that machine, that machine, that machine. It does that through PowerShell remoting. So you need to be able to enable PowerShell remoting, but this gives you instructions on how to enable that even when you're testing from Windows to Linux, from Linux to Windows and Mac and all variations like that. Here's how to specify custom input arguments, how to clean up after tests, how to, it shows you the log. So every time you execute a test, there's a log that's written. So it gives you details about that. And even there's an Atomic GUI, which is a web form, just a local web server, but a web form you can fill out of what you want your atomic test name to be, what the commands are, what the input arguments are, just a little form you fill out, and then it generates the YAML for you. And so if you wanted to contribute a new atomic test, you could use that form. And so that tells you about that there. Let's go back into the presentation at this point. And we need to skip down a ways. Yeah, so here's an example of an execution log. It tells you at this time, local and UTC, you ran this technique, this test from this host, And, that could be a remote machine. The user that ran it is this user, and the unique ID was this. So it does not include the output of the test. And none of the execution frameworks will tell you, was the attack successful? That's very hard to do, and success is defined differently by everyone. So it maybe is even impossible. So really, you need to use your detection capabilities to decide that, something actually ran or whatever. But that is a common question we get. Like, how do I know if the test worked? But worked is kind of hard to define, but no, it won't tell you that it worked. And the default execution logging won't even give you the output of the test. But there is an additional logging mechanism, which you can read about on that wiki, that will log in JSON format. And that includes every command you run and all the output that's thrown to the screen. And it's even written in a well-defined format that's importable to other tools, like the Purple Team reporting tool Vector. So now you can import everything you emulated into a Purple Team reporting tool, and you can show from campaign to campaign, or month to month. Like originally 3 months ago, we ran these 10 tests and we detected nothing by none of our products, and this time we detected 2 things by these 2 products. And over time, you get this great reporting of improvement over time, and also what tools are doing the most for you in your environment. So Vector is a cool tool. I talked about this already, that you could install Atomic Red Team on the same machine where you execute atomic tests. That'd be local execution. And so like scenarios where I think would be valuable to use Atomic Red Team are, you have some test system that's this G like represents a golden image, which is like your typical image you hand to a new hire. Something has the same software and security tools on it as a typical user, and you run these atomic tests on there, not necessarily on the main corporate network, but you do ship that telemetry from those tests to your production database, where you look for bad things happening in your environment. So you kind of seed your production database with this emulated data. And so you can validate your production detection still, even though you maybe aren't necessarily testing in production. And then this scenario down here is just doing that remotely. So you install Atomic Red Team on one machine, whatever operating system, and then you use PowerShell remoting to execute over to this endpoint, which in this case, it could actually be like a real user's endpoint. If you pick out atomic tests that you completely understand what they do and what their impact might be. I mean, some things like running ipconfig and a few other ARP commands, you can feel confident isn't going to break any of your systems. You could actually run that again. You could just target a user, an actual user out there, and you could say, run this atomic test, which is essentially these 5 commands against that machine, because I want to validate in real life on a real computer and real production that all this stuff works. So we can identify those atomics we know and trust as safe, and execute those against a remote machine. And the cool thing about doing that is that's much lighter touch. So we don't have to install Atomic Red Team. We don't have to put a big pile of scripted cyber attacks on their system and set off 100 alerts as we do it. We can say, hey, you over there, run these 5 commands. It's, we're not polluting their system and setting off 1 million alerts by installing Atomic Red Team. So with so many tests, 800 for Windows and several for Mac. Oh, I forgot. I want to show real quick. There is a link here under MITRE ATT&CK. There's an interactive matrix called the Navigator that we can look at, but we actually have a layer called MITRE ATT&CK ARC coverage, Atomic Red Team coverage. It shows a red box for every tactic that has at least 1 atomic test. So here's the entire defined MITRE ATT&CK space, and you can see that there's really good coverage. There's at least 1 atomic test written for, well over half of these things. And you can look at these, you can look at this graph for specifically for Windows or Mac or Linux, and you can see this is everything combined. But you can get a good idea. These layers are in that indexes folder and they're automatically updated. So if you were to add a new atomic test today, that index, this JSON file that it's rendering here, would be automatically updated. So if you refresh this page tomorrow, and there was a new test added here, that would turn red. So this is like a living, live, always up to date view of what the Atomic Red Team library has in it. So that's cool. And you learn about that in the lab. So if you read through those labs, you'll get them. So getting started can be overwhelming because there's so many tests. So I made a little like list of 20 atomics that would be good to just start playing with because they're not like overly complicated. They are more like using live off the land type techniques, so they don't get just automatically just blown up by AV and not allowed to run. So you don't have to turn off AV to run them. It's more like something like, yeah, maybe an admin would do this occasionally, but nobody else should be. Those type of tests that are just straightforward, easy to use. So I made that list as a way to just get started playing with Atomic Red Team and just start slow. When I started with Atomic Red Team, I started with a Excel spreadsheet and I said, I ran this test at this time. And here's the detections that went off. And, you know, I kept track of everything on a spreadsheet, but over time that morphed into, you know, keeping track of all our work in like Jira, and then automating all the stuff, you know, like, so I don't have to fill out a spreadsheet. I can just run a script that says you ran these tests and you got these detections, and constantly showing me where we're at. If you want to contribute, just remember on the wiki, there's a great page about how you can contribute. And I actually just recorded last week a half-an-hour video of how to actually do a pull request for Atomic Red Team through the web interface. So it's not any hard like command line kung fu or anything. It's just like you go to the YAML file, you click the little pencil button that says you want to edit it, and then you paste in your test. So it's, and you also get a free t-shirt from Atomic Red Team. So, and it's nice and like fuzzy. So it's totally worth it. Okay, so for your labs, you're gonna go to controlpanel.dchtraining.online and you just enter your access code, and there'll be a start button there that lets you start your VM. After you start it the first time, it'll list the IP address and the credentials for you to log in. You RDP to it. You'll have the same system I have here, and you'll click on the labs link from Chrome and you'll start the labs. And this is what it looks like. You put your access code in there. Once you start it here, it says you have 3 hours until the end of the day, Sunday, which is really like 12 a.m. on Monday. Then you'll RDP. There's instructions for RDPing from the various operating systems here if you need those. And you log in with those credentials. You can check how much time you've currently used with that button. If you're not going to use it for like, you know, half an hour, I would stop it here and then start it again when you come back, just if you want to make sure you can use your full 3 hours. And just a reminder, if you're interested in that 16-hour paid class from anti-siphon training that goes over the other attack emulation tools and Atomic Red Team in more detail, there's a link there. And that's it. I hope you like this demo about Atomic Red Team. There's a great Slack workspace supportive community that talks about all things Atomic Red Team that you can join. There's a link in the labs how to join that. And that's what I have. Thanks for coming to BSides. Thanks BSides organizers for organizing BSides. That's a great service and I love BSides. So that's all I got.
Thank you, Carrie. Do you have a second for questions if people have questions? Does anyone have any questions? You guys can come up to the mic, ask Carrie. You got her. Questions, comments, cries of outrage? I'm just kidding. I don't think she can see it. If you want a question, go for it now. We got like a few minutes.
Hi, Carrie. This is Ray Davidson. You can't see me, but I just thought.
Hey, Ray. Hello. Ray helped me. Good thing I said good things about SANS because Ray was my academic advisor when I was in the master's program. So I love Ray.
But I'm not at SANS anymore. So.
Well, yeah.
All right, Carrie, this is Ryan again. Thank you so much. Can we give her a round of applause? I know she can't. You're not gonna hear us, but we appreciate you taking the time, and I have the codes for who's interested. Thanks, Carrie.
Yeah, thank you.
All right, you guys are interested in the codes I have those up here. You guys want to take either the photo or write down. This is one of the codes. You just one of them. You only need one. I had 200.
Okay, 200.
So,
Okay,
yeah,
then
so-
go ahead and take one then.
Yeah.
Chris, where can I send like those links that are clickable and also get the code to get into Discord?
Okay.
I'll take one.
Okay. Yeah. Cool. You guys got it? Yep. Thank you. Sorry. Cool. Yeah. If you don't reach out on the Discord chat, and I can get you another code if that doesn't work.
Okay,
Okay.
okay, that works. Thank you.
And you want 3?
Yeah, I'll just.
This is in a font or L and 1 or L and I. Good.
Yeah, just finished
Awesome.
the Zoom meeting here.
You got 4?
Alrighty.
All right. Oh, okay. All right.
Grab another one that I have on.
Yeah.
What do you got next?
On the schedule?
Yeah.
So there's a full schedule thing out there. And here, this is not going to be the main session. Yeah, over there. So I'm Ryan, by the way.
I'm here.
Here.
What's my name?
Nice to meet you. Okay, I've heard. Awesome.
You
Yeah.
heard from my property.
Oh, yeah.
Yeah, so,
Oh, that's so cool. Yeah, that's awesome. Yeah, well, I'm glad you guys was. Yeah, I was so Carrie Roberts, and like she was a John camping person, and then Ira from Walmart, my twin brother who's at Walmart, wasn't pronounced here. So he's also like he's a security research at Walmart.
Walmart.
Yeah.
Okay.
So I know.
He was up there.
Yeah, he looks like me. So
Yeah. He was talking to, I was wondering, so.
yeah.
You were out and
Yeah.
inside the same
That's
time.
my twin brother. He's got longer hair, like hair and stuff. But yeah, and then yeah, so I got there as someone that was in cybersecurity at Walmart, and I expect you know.
Yeah.
Basic
That's
stuff.
good. That's good. I mean, I'm happy you guys are on that.
Is Jason Johnson's coming? Right?
Yes, he does. He's
Okay.
bringing the one that man.
Okay.
But he'll be here.
Okay, yeah. I saw his ticket. I was like, oh, he's coming. Great.
Yeah,
It's gonna be awesome.
So,
That's so cool.
you have a business card?
I don't, but hit me up on LinkedIn.
Yeah.
And then we have our Discord channel, so you guys
Okay.
are pretty active on that. Like I know you guys have done the healthcare security conference, so I'd be
Yeah.
interested in
Yeah,
that.
I've done it.
Oh, okay, yeah, you weren't kidding. Awesome. Yeah, it's wonderful. How long have you been working?
About 6 years.
6 years.
I'm going 6 years now.
Oh, cool.
Yeah, I come from
Yeah.
Chicago.
Oh, for sure. Yeah.
Yeah.
Okay, cool.
It's softwares.
Okay, yeah. Oh, cool. Yeah. Awesome. Never get you.
So they're doing that for.
Yeah.
And it's what?
Yeah, Ryan found. Yeah, I was wonderful meeting you. If you have questions, let me know. If I can help you, you know Matt too. So. All right. Is she still on there?
Yeah, did you want to?
Hey, Carrie. I am just, do you need anything else from
Yeah, I
us
just
here?
need to get access to Discord.
Can
I
you hear
wanted
me?
to post.
Oh, sorry, she can't hear me. Sorry, I can't.
Yeah, I can hear you.
Okay, good. Sorry. Did you have anything else you needed?
Yeah, I just want to get access to Discord. So if people have questions about the labs, I also want to post those links. I put them in the chat here just because maybe you could put them somewhere that people can access
Yes.
them as well. But
Yes. Let me
yeah.
get, I'm not a, I have to get, let me get Paul real quick. And then I can get the Discord access. Okay.
Okay.
Give me like 1 minute. I know you got to go too. So,
Yeah, do you just want to email me the Discord?
yes,
thing or
I can do
something?
that. Yep.
Okay, sounds
Okay,
good.
cool. All right. Thank you
Okay.
so much.
Yep. Bye
All
bye.
right. Have a good time at the beach.
Okay, bye bye.
All right. Bye.